Good evening, and welcome to The Gentle Scientist. Tonight, we drift into one of the most profound mysteries of existence, the science of healing. Settle in wherever you are. Adjust your pillow, pull your blanket close, and allow your eyes to grow heavy. This is a journey into the deepest wisdom your body possesses, the ancient and extraordinary ability to mend itself, to restore what has been broken, and to return to wholeness. Healing is not a human invention. It is written into the very fabric of life itself. Before there were doctors or medicines, before there were herbs or hospitals, there was healing. The first single cell that ever divided and survived did so because it could repair damage to its fragile membrane. Every living thing that followed, every plant, every animal, every microbe, inherited this fundamental capacity, and you carry within you mechanisms of repair and restoration that are billions of years old, refined across countless generations, more sophisticated than any technology we have yet created. Right now, even as you rest, your body is healing. Skin cells are dividing to replace those lost today. Immune cells patrol your bloodstream, seeking out and destroying potential threats. In your bones, old tissue is being carefully dismantled and new tissue laid down, keeping your skeleton strong. Your liver, that quiet miracle of an organ, is filtering toxins and regenerating its own cells. Your brain, as you drift toward sleep, is preparing to cleanse itself of the day's metabolic waste. All of this happens without thought, without effort, guided by instructions encoded in your DNA and refined by evolution's patient hand. Yet healing is also mysterious. Science can describe the mechanisms, can trace the molecular pathways and cellular responses, but cannot fully explain the intelligence that coordinates it all. How does a wound know when to stop bleeding and start rebuilding? How does the immune system distinguish between self and invader with such precision? These processes work with a wisdom that seems almost conscious, as if the body remembers what it should be and continuously works to return to that blueprint. For now, breathe deeply. Let your jaw unclench. Let your shoulders drop. And as we begin this exploration of healing, know that the very act of resting, of listening, of allowing yourself this time is itself a form of healing. The body restores itself best when given permission to do so. Tonight, give yourself that permission. Let's begin. Healing is one of the quietest miracles your body performs, and it happens more often than you might imagine. Right now, as you listen to these words, countless cells within you are working to restore balance, to mend what has been broken, to return you to wholeness. A paper cut on your finger seals itself within days. A bruise that bloomed purple beneath your skin slowly fades to yellow, then vanishes entirely. Even your liver, remarkable and resilient, can regenerate nearly half its mass if damaged, growing back like a forest after fire. But what is healing truly? It is more than the closing of a wound or the fading of pain. Healing is your body's conversation with itself, a dialogue between cells and molecules, all speaking a language written into your biology long before you were born. It is the process by which function and balance return after injury or illness has disrupted the delicate harmony of your tissues. To heal is to restore, to rebuild, to remember what wholeness felt like, and to journey back toward it. It helps to understand that healing, curing, and recovery, though often used together, are not quite the same thing. Curing means the complete elimination of disease, the removal of what caused harm in the first place. A bacterial infection, once treated with antibiotics, can be cured. The invader is gone. Recovery, meanwhile, is the larger journey back to health and normal function, encompassing not just the physical repair, but also the emotional and mental restoration that follows illness. Healing sits quietly between them. It is the body's own work, the biological process that knits tissue back together, calms inflammation, and rebuilds what was lost. You can heal without being cured, and you can recover while still healing. The body knows how to do this work, even when medicine cannot offer a cure. There are 3 primary ways your body heals, each suited to different kinds of damage. The first is regeneration, the most elegant of the 3. In regeneration, your body replaces damaged tissue with cells identical to what was lost. It is as though the injury never happened. Your liver does this with astonishing efficiency. So does your skin, in small amounts, and certain parts of your digestive tract. Regeneration is healing that restores the original, cell by cell, like an artist repainting a masterpiece from memory. The second type is repair, which is more common but less perfect. When tissue cannot be fully regenerated, your body forms scar tissue instead. Scars are strong, but they are not the same as the original tissue. They lack the flexibility, the function, the delicate architecture of what came before. The wound closes, the skin seals, but a pale line remains. That line is collagen, laid down quickly by cells called fibroblasts, serving as a patch, a bridge, a way to keep you whole, even if the repair is not identical to what was lost. Scar tissue is your body's pragmatism, choosing survival over perfection. The third type is resolution, the quietest and often overlooked. Resolution occurs when inflammation fades and normal tissue structure returns after the initial response to injury. Imagine a sprained ankle. Swelling rises, redness blooms, and movement becomes difficult. But over time, the inflammation resolves. The tissue returns to its usual state, function restored, without scarring or lasting change. Resolution is healing as a return to normal, the body's way of saying, the danger has passed. We can go back now. What determines which type of healing your body chooses? The answer lies in a web of factors, some within your control, many not. Age plays a role. Children heal faster than adults, their cells dividing with youthful eagerness, their tissues still elastic and quick to respond. As we grow older, healing slows. The cellular machinery becomes less efficient, and regeneration gives way more often to repair. Genetics, too, shapes how you heal. Some people are blessed with robust immune systems and resilient tissue. Others carry genetic variations that make healing slower or more prone to complications. Nutrition is another key. Your body cannot rebuild without the raw materials. protein to form new cells, vitamins like C to support collagen production, zinc to close wounds, and countless other nutrients that act as invisible architects. External factors matter just as much. The type of injury determines the response. A clean cut heals differently than a burn. The environment where healing occurs can either help or hinder. A wound kept clean and moist heals faster than one exposed to dirt and air. Medical intervention, when needed, can guide healing along the best path. But perhaps the most wondrous aspect of healing is that it is not a single event, but a dynamic, adaptive process. Your body does not heal the same way every time. It listens, it adjusts, it responds to the severity of the damage, the availability of resources, and the signals it receives from the environment. Cells communicate through chemical messengers, releasing signals that call for help, that direct traffic, that tell other cells when to arrive and when to stand down. Molecules float through your tissues like whispered instructions, coordinating efforts across vast distances, at least on the cellular scale. Healing is a choreography, each step timed precisely, each dancer knowing when to enter and when to exit the stage. Consider something as simple as a scraped knee, the kind every child knows. Within seconds of the injury, blood vessels constrict to slow bleeding. Platelets rush to the site, clumping together to form a temporary plug. Then comes inflammation, the body's alarm system, sending immune cells to clear away debris and bacteria. Fibroblasts arrive next, spinning collagen fibers to close the gap. New blood vessels sprout, bringing oxygen and nutrients to fuel the repair. Finally, the surface cells multiply, crawling across the wound like a living blanket until the skin is whole again. All of this happens without your conscious thought, without you directing a single cell. Your body simply knows. Even your liver, that quiet organ tucked beneath your ribs, holds extraordinary healing power. If part of it is damaged or even surgically removed, the remaining tissue can regenerate, growing back to nearly its original size within months. Liver cells, called hepatocytes, spring into action, dividing and multiplying, guided by growth factors and molecular signals until function is restored. It is one of the few organs in your body capable of such dramatic regeneration, a reminder that healing is not always about scarring over, but sometimes about true renewal. Healing happens in the everyday and the extraordinary. It is there, in the fading bruise on your shin, where red blood cells that leaked into tissue are slowly broken down and reabsorbed, their iron recycled, their remnants carried away. It is there, in the cut on your lip, that closes so quickly you barely remember injuring it, thanks to the rich blood supply and the remarkable regenerative capacity of mucous membranes. It is there, invisible, as your immune system clears away a viral infection. Your white blood cells hunting down invaders, your body learning and remembering so that next time it can respond even faster. The body's ability to heal is not unlimited, but it is astonishing. It is tailored to the context of the damage, efficient in minor injuries, slower but still determined in major ones. It is a process honed over millions of years of evolution, refined through countless generations until it became this quiet, automatic, ever-present force within you. You do not have to tell your skin to close a wound. Healing is woven into your very being, as natural as breathing, as inevitable as the sunrise. And as you rest tonight, know that healing is happening even now. Perhaps a small ache is fading. Perhaps cells are dividing somewhere deep within, replacing the old with the new. Perhaps your body is simply recovering from the day, restoring balance, preparing you for tomorrow. Healing is always there, working in the background, a quiet testament to the resilience of life itself. Long before microscopes revealed the mechanisms of cells, before laboratories hummed with the work of discovery, humans sought to heal. The quest to mend wounds, ease pain, and restore health is as old as consciousness itself, perhaps older. For as long as there have been injuries, there have been hands reaching out to comfort, voices offering hope, and minds searching for remedies in the world around them. Healing is one of humanity's oldest practices, woven into every culture, every tradition, every corner of the globe where people have lived and suffered and yearned to feel whole again. In the dim twilight of prehistory, when our ancestors huddled in caves and moved across vast landscapes, healing was already taking root. Shamans and healers emerged in tribal societies, figures who stood between the physical and spiritual worlds, interpreting illness as imbalance, as intrusion, as something requiring both practical intervention and sacred ritual. They gathered herbs from forests and plains, learning through trial and observation which plants could soothe a fever, which could numb pain, which could staunch bleeding. Willow bark for aches, yarrow for wounds, honey for infection. These remedies were passed down through generations, spoken softly around fires, taught from elder to apprentice, a living library carried in memory and practice. Healing in those ancient times was inseparable from the spiritual. Illness was not merely a broken body, but a disturbance in the harmony between person, community, and cosmos. Rituals accompanied remedies. Chants and dances called upon unseen forces. Minerals were ground into powders, believed to hold the strength of stone. Water from sacred springs was thought to carry purity and renewal. Whether these beliefs held literal truth mattered less than the comfort they provided. The sense that someone cared, that healing was not a solitary struggle, but a communal act of hope and intention. As civilizations rose along the banks of rivers, healing became more codified, more written, more deliberate. In ancient Egypt, over 3,500 years ago, physicians recorded their knowledge on papyrus scrolls. The Ebers Papyrus, one of the oldest medical texts ever discovered, contains over 800 remedies for ailments ranging from crocodile bites to baldness. The Egyptians understood infection, though not its cause. They used honey and willow, both now known to have antimicrobial and anti-inflammatory properties. They set broken bones with splints, stitched wounds with linen thread, and performed surgeries that leave modern scholars astonished at their boldness and skill. But their medicine was dual-natured. Alongside practical treatments, they invoked gods and goddesses, prayed to Sekhmet for protection from plague, and believed that magic and medicine were two sides of the same coin. Healing, to them, required both the hand of the physician and the favor of the divine. Across the Mediterranean, in the sunlit hills of Greece, a new voice arose. Hippocrates, often called the father of medicine, lived over 2,000 years ago and brought something revolutionary to healing: the idea that disease had natural causes, not supernatural ones. He observed patients carefully, noting symptoms, tracking the course of illnesses, and teaching that the body had an innate ability to heal itself if given the right conditions. His writings emphasized rest, diet, and balance. He believed in four humors: fluids within the body, blood, phlegm, yellow bile, and black bile, and that health depended on their equilibrium. Though we now know the humoral theory was incorrect, the principle behind it was sound. The body is a system, and healing requires restoring balance. The Hippocratic Oath, still echoed in medical practice today, reminded healers of their responsibility. First, do no harm. Medicine became not just a craft, but an ethical calling. The Romans, inheritors of Greek knowledge, expanded healing into public infrastructure. They built aqueducts to bring clean water, bathhouses for hygiene, and hospitals for soldiers wounded in distant campaigns. Roman physicians advanced surgery, developing instruments that look startlingly modern: scalpels, forceps, catheters, and pioneered techniques for removing arrowheads, amputating limbs, and treating cataracts. They understood that cleanliness mattered, even if they did not yet know about microbes. Galen, a Roman physician, studied anatomy by dissecting animals and wrote texts that would dominate medical thought for over 1,000 years. His work, though flawed in places, represented a commitment to understanding the body through observation and reason. Far to the east, in China, another system of healing was taking shape, one that would endure for millennia. Traditional Chinese medicine, or TCM, emerged from a worldview that saw the body as a microcosm of the universe, governed by the flow of qi, vital energy, through pathways called meridians. Health meant balance between opposing forces: yin and yang, cool and warm, passive and active. Illness arose when this balance was disrupted, when qi became blocked or depleted. Practitioners used acupuncture, inserting fine needles at specific points to redirect energy and restore flow. They prescribed herbal formulas, complex combinations of roots, leaves, and minerals, tailored to each individual's unique imbalance. Remarkably, modern science has begun to validate some of these ancient practices. Acupuncture, once dismissed as superstition, has been shown in clinical studies to reduce pain, ease nausea, and modulate the nervous system, though the mechanisms are still debated. The herbs used in TCM contain bioactive compounds, many of which are now being studied for their therapeutic potential. In India, a parallel system arose, one of the oldest healing traditions in the world. Ayurveda, meaning the science of life, taught that health depended on the balance of three doshas, elemental forces within the body: Vata, the energy of movement; Pitta, the energy of transformation; and Kapha, the energy of structure. Each person had a unique constitution, and healing meant restoring their individual balance through diet, herbs, yoga, meditation, and lifestyle. Turmeric, now celebrated for its anti-inflammatory properties, was used in Ayurvedic medicine for thousands of years. Ashwagandha, holy basil, and countless other plants formed a pharmacopoeia that modern researchers are only beginning to fully appreciate. Ayurveda's influence ripples through contemporary, holistic health, reminding us that healing is not one size fits all, but must honor the uniqueness of each person. When the Roman Empire fell, Europe descended into what historians call the Dark Ages, though in truth, light persisted in scattered places. Monasteries became sanctuaries of knowledge. Monks copied ancient medical texts by candlelight, preserving the wisdom of Greece and Rome when much else was lost to chaos and war. Monastic infirmaries cared for the sick, blending prayer with practical treatments, herbal teas, poultices, and rest. Healing became deeply entwined with faith. Pilgrims traveled to holy sites seeking miracles. Saints were invoked for specific ailments. Yet alongside the spiritual, a rough and ready medicine emerged. Barber surgeons who cut hair and also performed bloodletting and tooth extractions became common figures in towns. Hospitals, initially founded by religious orders, began to spread, offering refuge to the poor and sick, even if treatment options remained limited. The Renaissance, that great awakening of art and inquiry, brought a renewed fascination with the human body. Anatomists like Andreas Vesalius published detailed illustrations that corrected centuries of error. William Harvey traced the circulation of blood, revealing the heart as a pump, not a furnace. Paracelsus, a Swiss physician, challenged old doctrines and advocated for chemical remedies, laying the groundwork for pharmacology. The scientific method, careful observation, experimentation, and skepticism began to reshape healing from a blend of art and belief into something more systematic, more testable, more grounded in evidence. Meanwhile, across the world, indigenous peoples continued their own healing traditions, passed down through oral histories and intimate knowledge of their lands. Native American healers used plants like echinacea and willow bark. Aboriginal Australians developed the practice of bush medicine, employing hundreds of native species for wounds, infections, and pain. African healers worked with roots, barks, and rituals that connected physical healing with communal and spiritual well-being. These traditions, long overlooked or dismissed by colonial powers, are now being recognized and integrated into contemporary medicine. Many modern drugs have their origins in indigenous knowledge, plant compounds that traditional healers knew to be powerful long before laboratories could explain why. The true revolution in healing, however, came in the 19th century with the discovery of germ theory. For most of history, disease was attributed to bad air, imbalanced humors, or moral failing. Then scientists like Louis Pasteur and Robert Koch demonstrated that invisible microorganisms, bacteria, and viruses were the true culprits behind many illnesses. This single insight transformed healing. Antiseptics were introduced, making surgery safer. Joseph Lister pioneered sterile techniques, dramatically reducing infections. Vaccines were developed, training the immune system to fight off diseases before they took hold. Edward Jenner's smallpox vaccine, the first of its kind, would eventually lead to the eradication of a disease that had killed millions. The 20th century brought antibiotics, starting with penicillin, discovered by Alexander Fleming in 1928 when he noticed mold-killing bacteria in a petri dish. This chance observation opened the door to an era where infections that once meant death became treatable with a simple pill. Surgical techniques advanced rapidly, aided by anesthesia, which allowed procedures that were once unthinkable. Blood transfusions, organ transplants, chemotherapy all became possible as medicine moved from understanding to intervention, from observation to action. And yet, even in this age of high technology and molecular precision, the echoes of ancient healing remain. We still use willow bark's descendant, aspirin. We still value the holistic view that body and mind are connected. We still seek comfort in the presence of a caring healer. The history of healing is not a straight line from ignorance to enlightenment, but a winding path where old wisdom and new science walk side by side, each offering something the other lacks. If you could shrink yourself down, smaller than a grain of sand, smaller than the eye of a needle, smaller still, until you slipped between the fibers of your own skin, you would enter a world of astonishing activity. Here, at the microscopic level, healing is not a vague process, but a precise teamwork of cells and molecules, each playing its role with remarkable coordination. This is where healing truly begins. In spaces so small, they are measured in millionths of a meter, where decisions made by individual cells ripple outward to restore the wholeness of your entire body. Imagine a paper cut on your fingertip, small enough to seem insignificant, yet at the cellular scale, it is a catastrophe. The barrier of your skin has been breached. Blood vessels have been severed. Cells along the edges of the wound are damaged or dead. But within moments, the rescue begins. Your body does not panic. It has faced wounds like this countless times before, and it knows exactly what to do. The first responders are cells called platelets, fragments of larger cells that circulate in your blood. When they encounter the raw edges of torn tissue, they become sticky, clinging to the wound and to each other, forming a temporary plug. This is the beginning of a blood clot, a living bandage that seals the breach and prevents you from losing too much blood. But the clot is only the start. Beneath it, hidden from view, a far more complex process is unfolding. Among the most important workers in this hidden world are fibroblasts, cells that act as your body's builders and weavers. Fibroblasts are quietly present in almost every tissue, waiting for their moment. When an injury occurs, they receive chemical signals calling them to action. They migrate toward the wound, guided by molecular trails like breadcrumbs leading through a forest. Once they arrive, fibroblasts begin their work, producing collagen, the protein that gives your skin its strength and flexibility. Collagen fibers are laid down in careful patterns, forming a scaffold that other cells can use to rebuild the damaged area. Think of fibroblasts as carpenters constructing the framework of a house, beam by beam, until structure returns where chaos once reigned. But fibroblasts do not work alone. They are part of a much larger team, and one of their most remarkable colleagues is the stem cell. Stem cells are your body's reserve force, undifferentiated cells that hold the potential to become almost anything. They can transform into skin cells, muscle cells, blood cells, whatever the situation demands. In bone marrow, In fat tissue, in pockets scattered throughout your body, stem cells wait quietly, and when injury strikes, they are called forward. Chemical signals summon them to the wound site, where they begin to differentiate, taking on specialized roles to replace what has been lost. If the wound is in your skin, stem cells may become keratinocytes, the cells that form the protective outer layer. If a blood vessel has been damaged, it may become endothelial cells, lining the walls of new vessels. Stem cells are the body's ultimate adapters, capable of reading the needs of their environment and responding with precision. Another crucial player in this cellular drama is the macrophage, a type of immune cell whose name means big eater. Macrophages arrive at the wound site shortly after injury, summoned by chemical distress signals released by damaged cells. Their first job is cleanup. They engulf dead cells, debris, bacteria, anything that does not belong, digesting it and clearing space for new tissue to grow. But macrophages do far more than just clean. They also release signaling molecules called cytokines, which coordinate the activities of other cells, telling some to multiply, others to migrate, and still others to calm down once the danger has passed. Without macrophages, healing would be slower, messier, and more prone to infection. They are both janitors and conductors, clearing the stage and directing the orchestra. As healing progresses, new blood vessels must form. Tissue cannot repair itself without oxygen and nutrients, and these arrive through the bloodstream. The process of forming new blood vessels is called angiogenesis, and it depends on endothelial cells, which line the interior of every blood vessel in your body. When injury occurs, these cells receive signals, most notably a molecule called vascular endothelial growth factor, or VEGF. VEGF acts like a beacon, telling endothelial cells to sprout, to branch, to extend tiny tubular structures toward the wound. These new vessels are fragile at first, barely more than threads, but they carry life-giving blood to the site of injury, fueling the repair process. Angiogenesis is why healing wounds sometimes appear pink or red, flushed with the fresh blood flowing through newly formed capillaries. All of these activities, the migration of fibroblasts, the differentiation of stem cells, the cleanup by macrophages, the sprouting of blood vessels, are coordinated by an intricate network of molecular signals. Cells do not work in isolation. They communicate constantly, sending and receiving messages through chemical messengers. Cytokines are among the most important of these messengers, small proteins that can activate or suppress immune responses, promote inflammation or calm it, encourage cells to divide or tell them to rest. Growth factors are another class of signaling molecules. Epidermal growth factor, or EGF, stimulates skin cells to multiply, speeding the closure of wounds. Platelet-derived growth factor, or PDGF, recruits fibroblasts and smooth muscle cells to the injury site. Each of these molecules is a word in the language your cells use to talk to one another, a language refined over millions of years of evolution. Beneath the cells themselves lies another layer of organization, the extracellular matrix, or ECM. The ECM is not empty space, but a complex scaffolding made of proteins and sugars that surrounds and supports every cell in your body. It is composed largely of collagen, but also contains elastin, which gives tissues their stretch, and proteoglycans, which hold water and provide cushioning. During healing, the ECM is both a structure and a signal. Its composition influences how cells behave, whether they migrate, divide, or settle into place. Fibroblasts secrete new ECM components, rebuilding the scaffold as they go. In a sense, the ECM is the soil in which your cells grow, and healthy soil makes for healthy growth. Even your DNA, the instruction manual carried in the nucleus of every cell, plays a role in healing. Injury can cause DNA damage, breaks in the double helix, mutations that could lead to malfunction. But your cells have repair mechanisms for this as well. Enzymes patrol your DNA constantly, scanning for errors and fixing them before they can cause harm. When a wound occurs and cells are stressed, these DNA repair systems work overtime, ensuring that the new cells being created to replace the damaged ones are healthy and functional. Without this genomic vigilance, healing could lead to more problems than it solved. As days pass and the wound continues to close, your body faces a choice: regeneration or scar formation. In some tissues, under the right conditions, regeneration is possible. New cells grow that are nearly identical to the ones that were lost, restoring full function and appearance. Your liver can do this. So can the lining of your intestines, and to a limited extent, your skin. But in many cases, especially with deeper wounds, regeneration is not possible. Instead, your body opts for repair, forming scar tissue. Scar tissue is made mostly of collagen, laid down quickly and densely by fibroblasts. It is strong, but it lacks the complexity of the original tissue. There are no hair follicles in a scar, no sweat glands, no nerve endings in the same density. The collagen fibers are arranged differently, more parallel, less interwoven, which is why scars often appear paler and feel different to the touch. Scar formation is not failure, it is pragmatism. When speed and closure matter more than perfection, your body chooses survival. The molecular basis of this choice is fascinating. When wounds are small and shallow, growth factors like EGF dominate, promoting regeneration. But when wounds are large or deep, a different molecule takes the lead, transforming growth factor beta, or TGF-B. TGF-V shifts the balance towards scar formation, signaling fibroblasts to produce more collagen more quickly, creating a patch rather than a perfect repair. The balance between these signals determines whether you regenerate or scar, and scientists are now exploring ways to tip that balance, using drugs or growth factors to encourage regeneration, even in situations where scarring would normally occur. Much of what we know about cellular and molecular healing comes from decades of laboratory research. Scientists have used advanced imaging techniques, electron microscopy, confocal microscopy, time-lapse photography, to watch healing unfold in real time. They have tracked individual cells as they migrate toward wounds, observed the moment when stem cells differentiate, and measured the precise timing of molecular signals. In cell culture dishes, researchers can isolate fibroblasts, macrophages, or endothelial cells and study how they respond to different growth factors, different nutrients, different mechanical forces. These experiments have revealed that healing is not random but highly organized, governed by signal pathways, cascades of molecular interactions that translate external signals into cellular action. One breakthrough came from understanding how cells sense their environment. Cells have receptors on their surfaces, protein structures that bind to specific molecules and trigger internal responses. When a growth factor binds to its receptor, it sets off a chain reaction inside the cell, activating genes, producing proteins, changing behavior. This process, called signal transduction, is how a single molecule outside the cell can lead to dramatic changes within. It is also how healing can be so precisely tuned, with different signals activating different pathways depending on the type of injury, the tissue involved, and the stage of repair. To observe healing at the cellular level is to witness one of nature's most elegant solutions to the problem of damage. Your body does not simply close wounds, it orchestrates them. It calls the right cells at the right time, produces the right molecules in the right amounts, and knows when to stop, when to transition from inflammation to repair, from repair to remodeling. This is healing as a conversation, millions of voices speaking in chemical dialects, coordinating across distances vast by cellular standards, all working toward a single goal: to make you whole again. All around us, life is constantly mending itself. In the quiet corner of a garden, a broken stem seals its wound. In the depths of a forest pond, a salamander regrows a lost limb. Healing is not a human invention. It is written into the fabric of life itself, expressed in countless forms across every kingdom of living things. Plants, though rooted and silent, are masters of survival and repair. When a branch breaks or an insect tears through a leaf, the plant responds with a precision that rivals any surgical procedure. Unlike animals, plants cannot flee from danger. They must heal where they stand, and they have evolved remarkable ways to do so. The moment a plant is wounded, cells near the injury sense the change in pressure and mechanical stress. Within minutes, chemical signals cascade through the tissue, triggering a coordinated response that seals the breach and prevents infection. Scientists studying a small plant called Arabidopsis thaliana, a favorite in research laboratories, have observed this process in exquisite detail. When the plant's leaf is cut, cells at the wound edge begin to expand and divide rapidly, growing toward each other like hands reaching across a gap. The wound closes not through the formation of scar tissue, as in animals, but through actual regeneration of functional tissue. The cells remember what they were meant to be and become it again. Within hours, a barrier forms. Within days, the wound is barely visible. This cellular memory, this ability to rebuild what was lost, speaks to something fundamental about plant biology. Plants do not have specialized healing cells waiting in reserve. Instead, ordinary cells near a wound can transform, taking on new roles, producing the proteins and structures needed for repair. It is as if every cell carries within it the blueprint for healing, waiting for the signal to begin. The plant's body knows how to restore itself because restoration is part of its nature. Plants also produce an extraordinary array of chemical compounds, not for their own structure, but as medicine. These secondary metabolites, as scientists call them, include flavonoids, alkaloids, tannins, and countless others with names that sound like incantations. Many of these compounds have anti-inflammatory, antimicrobial, and wound-healing properties. When a plant is injured, it often increases production of these chemicals, creating a protective shield against infection. Humans have learned to harvest these compounds, using them in traditional medicine for thousands of years. Modern research has begun to validate what ancient healers intuited. Extracts from plants like aloe vera, calendula, and turmeric have been shown in laboratory studies to accelerate wound healing in animal tissue. Under the microscope, researchers observe increased collagen synthesis, faster formation of new blood vessels, and reduced inflammation when these plant compounds are applied to wounds. The plants are sharing their healing wisdom, offering molecules shaped by millions of years of evolution to help other living things mend. In the animal kingdom, healing takes on even more diverse forms. Most animals, like humans, heal wounds through a process that involves inflammation, tissue formation, and remodeling. A cut seals itself with a blood clot. Immune cells clear away debris, new tissue fills the gap, and eventually a scar forms. This is repair, not regeneration. The new tissue is functional, but different from what was lost. It is the body's compromise, choosing speed and closure over perfect restoration. Yet some animals have retained abilities that seem almost miraculous. The axolotl, a salamander that spends its life in water, can regrow entire limbs, complete with bones, muscles, nerves, and skin. If its leg is severed, a mass of cells called a blastema forms at the wound site. These cells, somehow released from their specialized fates, become stem-like again, capable of forming any tissue the limb requires. Over weeks and months, the limb rebuilds itself, faithful to the original, without scar, without error. Scientists have studied these creatures with wonder and frustration, trying to understand what they possess that mammals have lost. The answer seems to lie in the cellular environment and the signals that control cell behavior. In regenerating animals, inflammation is brief and tightly controlled. Cells receive signals that tell them not just to close the wound, but to recreate what was there before. The genes involved are ancient, present in many animals, including humans. But in mammals, these genetic programs are silenced, overridden by pathways that prioritize rapid healing over perfect restoration. There are exceptions even among mammals. Deer regrow their antlers every year, a feat of regeneration that produces bone, blood vessels, nerves, and skin at a rate faster than any other mammalian tissue. Young mice, if injured within the first few days of life, can sometimes regenerate the tips of amputated digits. These glimpses suggest that the capacity for regeneration has not been entirely lost, only suppressed. Researchers are now asking whether it might be possible to awaken these dormant pathways. By studying the molecular signals present in regenerating animals, they hope to coax mammalian cells into behaving more like salamander cells. Early experiments have shown promise. When certain proteins are applied to mouse wounds, tissue regeneration improves and scar formation decreases. The dream of regrowing a lost limb or repairing a damaged heart without scarring is still distant, but it no longer seems impossible. Even more humbling is the realization that single-celled organisms, the simplest forms of life, have been healing themselves for billions of years. A bacterium damaged by ultraviolet light can repair its DNA using enzymes that cut out the damaged section and rebuild it correctly. A protozoan, torn apart by mechanical stress, can reseal its membrane within seconds. These are not conscious acts. They are automatic responses, encoded in the genome, refined by evolution, as essential to survival as eating or reproducing. The plants outside your window and the animals in the forests and oceans are all engaged in this same ancient practice. They are healing constantly, invisibly, without fanfare. A tree with a gash in its bark slowly grows new wood around the wound, eventually enclosing it completely. The scar remains, but the tree lives on, stronger for having overcome the injury. A fish with torn fins regenerates them, often within days, the delicate rays rebuilding themselves cell by cell. A spider that loses a leg will regrow it at the next molt, emerging whole again. What all of these processes share is a kind of patience, an acceptance that healing takes time. Plants do not rush their repairs. Animals do not force their wounds to close faster than the cells can manage. There is a rhythm to healing, a pace set by biology, not by will. The body, whether plant or animal, human or otherwise, knows this rhythm. It follows it faithfully, building one cell at a time, one molecule at a time, until wholeness is restored. Studying healing in other species teaches us humility. We are not the pinnacle of healing ability. In some ways, we are less capable than a newt, less resilient than a tree. But we are part of the same continuum, the same unbroken thread of life that has been mending itself since the first cells divided in ancient seas. The mechanisms that heal a cut on your finger are cousins to the mechanisms that seal a torn leaf. The immune cells that protect you from infection are variations on themes first played out in simpler organisms hundreds of millions of years ago. And right now, as your eyelids grow heavy and your breathing slows, your body is preparing for its nightly ritual of restoration. A process so ancient and so essential that without it, no wound would close, no memory would form, no cell would renew itself completely. Sleep is not simply rest. It is a transformation. Every night, without thought or effort, your body becomes a symphony of repair. Tissues mend themselves. The brain cleanses itself of the day's debris. The immune system strengthens its defenses. All of this happens in silence, in the deep hours when you are least aware, yet most alive with healing. Scientists have discovered that sleep moves through stages, each one a different chapter in the story of renewal. In the early hours, you descend into slow-wave sleep, a state so deep that your brain waves stretch out like gentle ocean swells. This is when the body does its most intensive physical work. Human growth hormone floods through your bloodstream, released from the pituitary gland in pulses that peak during these quiet depths. This hormone travels to every corner of your body, stimulating cells to divide, muscles to rebuild, bones to strengthen. If you have ever wondered why children sleep so much, it is because they are quite literally growing in their sleep. But even in adulthood, even as you rest tonight, this same hormone continues its work. Every micro tear in a muscle fiber from the day's movement is being rewoven. Every bone that bore your weight is being fortified at the microscopic level. The body knows that healing requires stillness. That restoration cannot happen while we are in motion. Later in the night, you enter REM sleep, where dreams flicker like shadows on water. Here, the brain takes center stage. While your eyes move rapidly beneath closed lids and your body lies perfectly still, your mind is organizing itself. Memories from the waking hours are being sorted, strengthened, filed away. Emotional experiences are being processed and integrated. The brain is not resting during REM sleep. It is working, connecting neurons in patterns that will shape who you are when morning comes. But perhaps the most remarkable discovery of recent years is what happens in your brain during sleep that you cannot see or feel. Deep within, there exists a drainage system called the lymphatic system. Think of it as the brain's nighttime cleaning crew. During waking hours, this system operates at only a fraction of its capacity. But when you sleep, the spaces between brain cells expand by nearly 60%, allowing cerebrospinal fluid to flow through like a gentle river, washing away metabolic waste and toxins that accumulated during the day. Among the debris cleared away are proteins like beta amyloid, which, if left to accumulate, can form the plaques associated with Alzheimer's disease. Every night of quality sleep is a night of protection, a quiet defense against the slow fog of neurodegeneration. Your brain is bathing itself in clear fluid, emerging refreshed, ready to think and remember and dream again. This cleansing cannot happen when you are awake. It requires the deep surrender of sleep. The immune system, too, has learned to use the cover of darkness for its most important work. While you sleep, immune cells patrol your body with heightened vigilance. T cells, those guardians against infection, become more effective at recognizing and destroying infected cells during sleep. Studies have shown that people who sleep well produce more antibodies after receiving a vaccine compared to those who are sleep deprived. The immune system's memory, its ability to remember past infections and respond more quickly in the future, is consolidated during sleep. Much like other memories, when you are sick, you feel an overwhelming urge to sleep. This is not a weakness, it is wisdom. Your body is directing all available resources toward fighting infection, and sleep is the state in which this fight can be waged most effectively. Inflammatory signals, called cytokines, rise during sleep, coordinating the immune response. Sleep and immunity are so intertwined that losing even a few hours of sleep can measurably weaken your defenses, making you more susceptible to illness. But sleep does more than fight disease. It actively heals physical wounds. Research has shown that people who sleep well after surgery heal faster than those who sleep poorly. Wounds close more quickly, infections are less common, and pain is reduced. The reasons are molecular. During deep sleep, blood flow to muscles and tissues increases, delivering oxygen and nutrients needed for repair. Collagen, the protein that forms the scaffolding of healing tissue, is produced more efficiently when the body is at rest. Even the simple act of relaxation, that gentle descent from the day's tensions, begins the healing process before sleep arrives. When you relax, truly relax, your nervous system shifts from the sympathetic state of fight or flight to the parasympathetic state of rest and digest. Your heart rate slows, your breathing deepens, blood pressure drops. The stress hormone cortisol, which in high levels can suppress immune function and slow healing, begins to fall like a tide going out. Chronic stress keeps cortisol elevated, creating a state of constant alert that exhausts the body's resources. But relaxation, practiced regularly, creates windows of recovery. In these moments, inflammation decreases. The body stops preparing for danger and starts preparing for renewal. Studies using techniques like meditation, progressive muscle relaxation, and guided imagery have documented measurable improvements in immune markers, reduced inflammation, and accelerated healing in patients recovering from surgery or managing chronic conditions. There is something almost magical about how deeply interconnected sleep and mental health are with physical healing. People who sleep poorly often struggle with anxiety and depression, and those who are anxious or depressed often sleep poorly. It is a cycle that can feel impossible to break. Yet when sleep improves, even slightly, the benefits ripple outward. Mood lifts, pain becomes more tolerable. The body, no longer fighting the exhaustion of sleeplessness, can direct its energy toward healing. A recent study from the University of Sheffield followed thousands of people and found that improving sleep quality led to measurable improvements in mental health, including reductions in anxiety, depression, and feelings of loneliness. The researchers noted that sleep might be one of the most accessible interventions for supporting mental well-being. Unlike many treatments, sleep requires no prescription, no cost, only the willingness to prioritize rest in a world that often demands wakefulness. Scientists have observed how quickly the body responds to even small improvements in sleep. In one study, researchers examined wound healing in healthy adults and found that those who slept well showed faster closure of small experimental wounds compared to those who were sleep-deprived. The difference was visible within days. Another study looked at athletes recovering from injuries and found that those who prioritized sleep returned to competition faster and with fewer complications. The architecture of sleep, the way it cycles through stages in roughly 90-minute intervals, seems designed for different aspects of healing. The first half of the night is dominated by deep, slow-wave sleep when physical restoration peaks. The second half contains more REM sleep when emotional and cognitive processing occur. Interrupting either phase disrupts the full healing potential of sleep. This is why fragmented sleep, even if the total hours seem adequate, leaves you feeling unrefreshed. and why chronic sleep disruption is linked to slower recovery from illness and injury. In hospitals, where healing should be a priority, sleep is often disrupted by light, medical procedures, and the unfamiliarity of the environment. Researchers have begun advocating for sleep-friendly hospital designs and protocols, recognizing that protecting patient sleep is not a luxury, but a medical necessity. When patients sleep better in hospitals, they heal faster, experience less pain, require fewer medications, and are discharged sooner. Even the temperature of your sleeping environment affects healing. The body's core temperature naturally drops during sleep, and this cooling is part of the signal that initiates deep sleep. Studies suggest that a slightly cool room, around 16 to 19 degrees Celsius, supports better sleep quality. Warmth can be comforting, but too much heat disrupts the body's ability to reach the deeper stages of sleep where the most intensive healing occurs. Light, too, plays a crucial role. The eyes contain specialized cells that detect light and send signals to the brain's master clock, the suprachiasmatic nucleus, which regulates circadian rhythms. Exposure to bright light, especially blue light from screens, in the evening delays the release of melatonin, the hormone that signals the body to prepare for sleep. This delay can push back sleep onset and reduce total sleep time, creating a debt that accumulates night after night. Healing suffers when sleep suffers. Ancient cultures understood the importance of rest and relaxation for healing long before modern science could measure it. They created rituals around sleep, evening prayers, herbal teas, storytelling by firelight, all designed to ease the transition from wakefulness to sleep. Today, we call these practices sleep hygiene, but the principle remains the same. The body heals best when given time, darkness, quiet, and safety. As you lie here now, breathing slowly, letting the day's worries dissolve, your body is already beginning its nightly work. Every cell is listening for the signal that it is safe to rest, to repair, to renew. The longer you sleep, the deeper you sleep, the more complete this restoration becomes. Sleep is not a pause in living. It is living at a different frequency, one where healing happens without effort or thought. In a world that glorifies productivity and constant motion, sleep can feel like surrender. But it is not giving up. It is giving in to the body's deepest needs. It is trusting the ancient processes that have kept our species alive for hundreds of thousands of years. Every night of quality sleep is an investment in health, a gift to your future self, a quiet act of self-compassion. There is a frontier where thought becomes flesh, where belief can bend the arc of recovery, where the landscape of your mind shapes the terrain of your body. This frontier is not mystical, though it may feel that way. It is biological, measurable, and increasingly understood by science. The mind and body are not separate kingdoms, but one continuous realm, communicating through highways of nerves, rivers of hormones, and whispered signals between brain and immune system. What you think, what you feel, what you believe. These invisible forces can influence how quickly you heal. how much pain you experience, and even whether you survive. For most of medical history, the body was treated as a machine, a collection of parts that could break down and be repaired without reference to the person inhabiting it. Emotions were considered irrelevant to physical health, distractions at best, complications at worst. But this view has crumbled under the weight of evidence. We now know that psychological factors, stress, anxiety, depression, hope, optimism, are not merely accompaniments to illness, but active participants in the healing process. Your emotional state can strengthen or suppress your immune system, speed or slow tissue repair, and determine whether recovery is swift or faltering. Consider stress, that familiar companion of modern life. When you experience stress, whether from an argument, a deadline, or worry about illness itself, your body responds with an ancient cascade designed for survival. The hypothalamus, a small region at the base of your brain, signals the adrenal glands to release cortisol and adrenaline, hormones that prepare you to fight or flee. Your heart rate increases, blood pressure rises, energy is diverted away from long-term projects like digestion, reproduction, and yes, healing, toward immediate survival. This response is brilliant for escaping a predator, but when stress becomes chronic, when cortisol floods your system day after day, the consequences are profound. Chronic stress suppresses the immune system, making you more vulnerable to infection and slowing the repair of damaged tissue. Wounds heal more slowly in stressed individuals, a fact documented in numerous studies. In one remarkable experiment, researchers gave small punch biopsies to students before and during exam periods and found that wounds inflicted during high-stress times took significantly longer to heal. Stress, quite literally, gets under your skin, but the mind's influence flows in both directions. Just as negative emotions can hinder healing, positive psychological states can enhance it. Hope, optimism, a sense of control, these qualities have been linked to better health outcomes across a wide range of conditions. This is not merely about feeling better emotionally, though that matters too. It is about measurable changes in physiology. Optimism is associated with lower levels of inflammatory markers in the blood, stronger immune responses, and healthier cardiovascular function. One of the most fascinating windows into the mind's power over the body is the placebo effect. A placebo is an inert substance, a sugar pill, a saline injection, something with no active medical ingredients. Yet when people believe they are receiving real treatment, their bodies often respond as if they are. Pain diminishes. Symptoms improve. In some cases, measurable biological changes occur. Brain imaging studies have shown that when people take placebos, they believe to be painkillers. Their brains release endorphins and activate the same pain relief pathways that real medications trigger. The expectation of relief creates the relief itself, not through magic, but through the brain's ability to modulate its own chemistry. The placebo effect extends beyond pain. Studies have documented placebo responses in depression, anxiety, Parkinson's disease, and even immune function. In one study, patients with psoriasis were treated with ultraviolet light a standard therapy. Half were told the treatment would work especially well, while the other half received no such suggestion. Those who expected better results showed greater improvement, even though the physical treatment was identical. The mind, it seems, can amplify or diminish the effects of real treatments, acting as a dial that turns healing up or down. This power is not limitless. The mind is not magic, and to suggest otherwise is both cruel and false. But within its limits, the mind is a potent ally in healing, one that medicine is only beginning to harness systematically. The field of mind-body medicine has emerged to study and apply these principles using techniques like meditation, mindfulness, guided imagery, and relaxation training to support physical health. Meditation, in particular, has been subjected to rigorous scientific scrutiny. When you meditate, you typically focus your attention, often on your breath, and gently redirect your mind when it wanders. This simple practice has profound effects. Studies using functional MRI scans have shown that regular meditation changes the structure and activity of the brain. Regions involved in attention, emotion regulation, and self-awareness become more active and, over time, physically larger. Meanwhile, the amygdala, a brain region associated with fear and stress responses, shows reduced activity and may even shrink. These changes are not subtle. They can be observed after just 8 weeks of regular practice. The effects ripple outward from the brain into the body. Meditation lowers cortisol levels, reducing the harmful effects of chronic stress. It decreases markers of inflammation in the blood, substances like C-reactive protein and interleukin-6 that are linked to heart disease, diabetes, and other chronic conditions. Meditation has been shown to improve immune function, with one study finding that people who practiced mindfulness meditation produced more antibodies in response to a flu vaccine compared to non-meditators. The practice seems to enhance the activity of natural killer cells, immune cells that hunt down viruses and cancer cells, offering the body a stronger defense. Guided imagery, another mind-body technique, involves visualizing healing processes in the mind, imagining white blood cells attacking infections, or picturing wounds closing and tissues mending. While it may sound fanciful, research suggests it can have real effects. Athletes use similar techniques to enhance performance and recovery from injuries, visualizing muscles repairing and strengthening. The brain, it turns out, does not always distinguish sharply between imagined experiences and real ones. Visualizing healing may activate some of the same neural pathways that govern actual healing, priming the body to follow the script the mind has written. The mechanisms underlying these mind-body effects are complex, but increasingly well understood. The brain communicates with the immune system through multiple channels. Nerves extend from the brain into lymphoid organs, like the spleen and thymus, directly influencing immune cell activity. Hormones released by the brain travel through the bloodstream, carrying messages that can activate or suppress inflammation. The autonomic nervous system, which controls unconscious functions like heart rate and digestion, has 2 branches: the sympathetic, which revs you up in response to stress, and the parasympathetic, which calms you down. Mind-body practices shift the balance toward the parasympathetic, promoting what is sometimes called the rest and digest state, a physiological environment far more conducive to healing than the constant arousal of chronic stress. Neuroscientific research has revealed that the brain's control over pain is particularly striking. Pain is not simply a signal sent from an injured area to the brain, a one-way message. It is actively constructed by the brain, which interprets signals from the body and decides how much pain to generate based on context, expectation, and emotion. This is why soldiers sometimes report feeling no pain from severe wounds sustained in battle, why athletes can push through injuries during competition, and why placebos can reduce pain so effectively. The brain has its own pharmacy, producing endorphins, enkephalins, and other natural painkillers that it can release when it believes relief is coming. Mind-body techniques teach people to tap into this internal pharmacy, using breath, attention, and intention to modulate pain without drugs. Clinical applications of mind-body medicine are expanding rapidly. Hospitals now offer mindfulness programs for patients with chronic pain, anxiety disorders, and cancer. Surgeons have found that patients who practice relaxation techniques before surgery experience less pain afterward, require lower doses of anesthesia, and recover more quickly. In mental health care, mindfulness-based therapies have become frontline treatments for depression and anxiety, with effectiveness comparable to medication in many cases, even in intensive care units where patients are gravely ill. Music therapy, guided relaxation, and family presence, all of which engage the mind and emotions, have been shown to improve outcomes and shorten hospital stays. The empowerment that comes from mind-body practices is itself therapeutic. Illness can make people feel helpless, as though their bodies have betrayed them, and recovery depends entirely on doctors and drugs. Mind-body medicine returns some measure of control, reminding patients that they are not passive recipients of care, but active participants in their healing. This shift in perspective, from helplessness to agency, can transform the experience of illness, making it less frightening and more manageable. Yet, it is important to strike a balance. The power of the mind in healing should not be used to blame people for their illnesses or to suggest that those who do not recover simply did not think positively enough. Illness is complex, shaped by genetics, environment, access to care, and factors far beyond individual control. To place the burden of healing entirely on the mind is both inaccurate and unkind. The mind is one factor among many, powerful but not omnipotent, capable of influencing but not dictating outcomes. What we can say with confidence is this: your thoughts and emotions matter. How you respond to stress, whether you cultivate hope or despair, whether you engage in practices that calm your nervous system or live in a state of constant tension. These things shape your body's ability to heal. The mind-body connection is not metaphorical. It is anatomical, biochemical, and real. Your brain and your immune system are in constant conversation, and the tone of that conversation, anxious or calm, hopeful or despairing, influences how effectively your body can repair itself. So as you settle into sleep tonight, each breath you take, each moment of calm you cultivate, each time you choose to let worry drift away like clouds across a quiet sky, you are supporting your body's work. Healing happens in the silence of rest, in the softness of self-compassion, in the gentle assurance that you are more resilient than you know. The mind holds power, yes, but it is not the power to force or control. It is the power to allow, to nurture, to create conditions where healing can unfold naturally, as it has been designed to do since the beginning of time. There is a realm of healing that cannot be held in a test tube or seen under a microscope, yet it has existed as long as human consciousness itself. It dwells in the quiet spaces where suffering meets meaning, where pain encounters purpose, where the invisible architecture of belief shapes the body's response to illness and injury. Let's explore the mysterious intersection of spirituality and healing, a place where science is only beginning to illuminate what human hearts have known for thousands of years. Spirituality means different things to different people. For some, it is found in prayer, in the familiar words of ancient texts. For others, it lives in meditation, in the stillness between thoughts. Some discover it in nature, in the presence of something vast and untamed. Others find it in community, in the gathering of souls who share a common faith or practice. What unites these diverse expressions is a sense of connection to something larger than the self, to a source of meaning that transcends the material world. Scientists trained to measure and quantify have struggled with how to study spirituality. How do you design an experiment around faith? How do you control for hope? Yet over the past few decades, researchers have found ways to examine the effects of spiritual practices on health. And what they have discovered is remarkable. People who engage regularly in spiritual or religious practices, whether prayer, meditation, attendance at services, or contemplative reading, tend to live longer and experience lower rates of chronic diseases. Large epidemiological studies, following thousands of people over many years, have documented these patterns. Regular spiritual practice is associated with reduced rates of cardiovascular disease, stroke, and certain cancers. The reasons are complex and interwoven. Spiritual communities often encourage healthy behaviors, discouraging smoking and excessive drinking, promoting moderation and care for the body as sacred. But the effects persist even after accounting for these lifestyle factors, suggesting that something deeper is at work. Perhaps it begins with stress. Modern life, with its relentless demands and constant uncertainties, keeps many people in a state of chronic activation. The body's stress response, designed for brief emergencies, runs continuously, flooding the system with cortisol and adrenaline. Over time, this takes a toll. The immune system weakens, inflammation rises, blood pressure climbs. The body, exhausted by false alarms, begins to break down. Spiritual practices offer a counterbalance. Prayer and meditation activate the relaxation response, a physiological state discovered by Dr. Herbert Benson at Harvard Medical School in the 1970s. During this state, heart rate slows, blood pressure drops, breathing deepens, and the production of stress hormones decreases. Brain wave patterns shift, moving from the rapid beta waves of active thinking to the slower alpha and theta waves associated with deep relaxation and meditative states. This is not merely feeling calm. It is a measurable shift in the body's operating system. When people pray or meditate regularly, these moments of calm accumulate, creating islands of peace in a sea of stress. Over weeks and months, the nervous system recalibrates. The body spends less time in fight or flight mode and more time in the parasympathetic state, where healing flourishes. Inflammation markers in the blood decrease. Immune function improves. Even gene expression changes, with genes related to inflammation being downregulated and genes related to immune function being enhanced. But spirituality offers more than relaxation. It provides a framework for making sense of suffering. When illness strikes, when injury occurs, the body is not the only thing that needs healing. The mind struggles with questions. Why is this happening? What does it mean? Will I recover? Without answers, these questions can become a source of additional suffering, a weight that makes the physical burden even harder to bear. Spirituality, in its many forms, offers narratives that help people locate their suffering within a larger story. For some, faith provides assurance that their pain has purpose, that even in darkness, they are not alone, that a benevolent presence watches over them. For others, spiritual practice cultivates acceptance, teaching them to observe pain without adding layers of resistance and fear. The Buddhists speak of the difference between pain and suffering, the first being inevitable, the second arising from how we relate to the first. Meditation trains the mind to be present with discomfort without amplifying it, creating a spaciousness around pain that makes it more bearable. Research has documented these effects. Studies of patients with chronic pain who engage in mindfulness meditation show not only reduced pain intensity, but also decreased emotional distress and improved quality of life. Brain imaging reveals that meditation alters the way pain is processed in the brain, reducing activity in regions associated with the emotional suffering of pain, while leaving the sensory perception relatively intact. The pain may still be present, but it no longer dominates the entire experience of being alive. Social support, a crucial component of many spiritual traditions, also plays a powerful role in healing. Humans are deeply social creatures. We heal better in the presence of others who care for us. Spiritual communities provide this presence, offering practical help during illness, visiting the sick, bringing meals, offering prayers. But beyond the practical assistance, these communities offer something equally vital: the assurance that one is valued, remembered, held in the thoughts and hearts of others. Loneliness, research shows, is as harmful to health as smoking or obesity. It increases inflammation, suppresses immune function, and accelerates cognitive decline. By contrast, strong social connections strengthen resilience, improve recovery outcomes, and extend life. When people gather to pray for someone who is ill, whether or not that prayer has a direct supernatural effect, it creates a web of care that tangibly supports healing. The person knows they are not forgotten, not alone in their struggle. Some studies have attempted to measure whether intercessory prayer offered by others on behalf of a patient, affects health outcomes directly. These studies are controversial, and their results mixed. Some show small positive effects, others show none. The methodological challenges are immense. How do you account for prayers offered outside the study? How do you blind patients to whether they are being prayed for? Despite these difficulties, the research continues because the question matters deeply to many people. What is clearer is that people who pray for themselves, who engage personally in spiritual practice during illness, report better outcomes. They experience less anxiety and depression. They cope better with pain. They describe finding meaning and even growth through their suffering. Cancer patients who identify as spiritual or religious often report a better quality of life during treatment, not because the cancer responds differently, but because they possess resources for navigating the emotional and existential challenges of illness. There is a mystery here that science cannot fully penetrate. In hospitals, chaplains witness moments that defy easy explanation. A dying person, agitated and restless for days, suddenly becomes peaceful after receiving the last rites or a blessing. A patient facing a difficult surgery describes feeling surrounded by a presence that calms their fear. These subjective experiences, though not measurable, are real to those who live them, and they shape the healing process in ways both subtle and profound. Scientists studying the physiology of spiritual practices have discovered measurable changes that accompany these subjective experiences. During deep meditation or contemplative prayer, blood flow to the frontal lobes of the brain increases, while activity in the parietal lobes, which help maintain a sense of the body's boundaries, decreases. Some researchers speculate that this pattern creates the sense of boundary dissolution, the feeling of connection or unity that mystics across traditions have described. Whether this reflects contact with a transcendent reality or an altered brain state is a question science cannot answer. But the healing effects of the experience can be documented. Forgiveness, a spiritual practice emphasized in many traditions, has also been linked to better health outcomes. Holding on to resentment and anger keeps the body in a state of stress. Studies show that people who harbor grudges have higher blood pressure and more cardiovascular problems than those who practice forgiveness. Learning to forgive, whether through religious rituals of confession and absolution, or through secular therapeutic processes, appears to release the body from chronic stress, allowing healing to proceed more freely. Gratitude, another spiritual practice, has been studied extensively in positive psychology. People who regularly practice gratitude, perhaps through keeping a gratitude journal or through prayer that includes thanksgiving, show improved mood, better sleep, and stronger immune function. The act of noticing and appreciating what is good, even in the midst of difficulty, seems to shift the nervous system toward a more healing conducive state. Yet spirituality and healing are not a simple equation where more prayer equals faster recovery. Some people experience their faith as a source of conflict during illness, wondering if they are being punished, if their suffering reflects some failure of belief. These negative spiritual experiences can actually worsen health outcomes, increasing depression and slowing recovery. Healing through spirituality requires not just the presence of belief, but a relationship with that belief that provides comfort rather than additional burden. Healthcare providers are increasingly recognizing the importance of addressing spiritual needs as part of comprehensive care. Many hospitals now employ chaplains trained to work with diverse faith traditions, offering spiritual support that respects each patient's unique beliefs. Studies show that when spiritual care is integrated into treatment, patients report greater satisfaction with their care and often experience better outcomes. In fact, you need not hold any particular belief for healing to find you. But if you do carry faith, if you practice prayer or meditation, if you find solace in Scripture or strength in community, know that these are not separate from your physical healing. They are part of it, woven into the same fabric that includes cells and molecules and immune responses. The body and the spirit, however you conceive of it, are not divided. They speak to each other in languages we are only beginning to understand. We live in an age where technology and biology are merging, where machines can see inside living bodies without breaking skin, where damaged organs can be printed layer by microscopic layer, where the very code of life can be edited like text on a page. The revolution began quietly, with the first crude X-rays that let physicians glimpse bones through flesh. But it has accelerated into something that would seem like magic to healers of previous centuries. Artificial intelligence now examines medical images with superhuman precision, detecting cancers so small they escape the human eye, identifying patterns in retinal scans that predict heart disease years before symptoms appear. These algorithms, trained on millions of images, learn to recognize the subtle signatures of illness that even experienced physicians might miss. In hospitals across the world, AI systems assist in diagnosis, processing vast amounts of data, patient histories, lab results, genetic profiles, imaging studies, and synthesizing them into recommendations. The machine does not replace the physician's judgment, but it augments it, offering a second opinion that never tires, never overlooks a detail, never lets bias cloud its analysis. Studies show that when doctors and AI work together, diagnostic accuracy improves beyond what either could achieve alone. It is a partnership between human intuition and computational power, each compensating for the other's limitations. Surgical theaters have been transformed by robotics, where once a surgeon's hands, however skilled, were limited by their size and the slight tremor inherent in all human movement. Robotic systems now translate the surgeon's intentions into movements of impossible precision. The Da Vinci surgical system, used in millions of procedures, allows operations through incisions barely larger than a buttonhole. Instruments no thicker than a pencil, equipped with tiny cameras and lights, navigate inside the body with movements so fine they can suture blood vessels smaller than a thread. The surgeon sits at a console, hands controlling the robot's arms through intuitive motions, while a three-dimensional view of the surgical field fills the screen. The robot filters out hand tremors, scales movements so that a centimeter of hand motion becomes a millimeter of instrument motion, and allows access to spaces the human hand could never reach. Patients wake from surgery with smaller scars, less pain, reduced blood loss, and faster recovery times. What once required weeks of hospitalization now often allows patients to return home the same day. But perhaps the most profound revolution is happening at the level of cells and genes themselves. Stem cell therapy, once purely theoretical, is now treating diseases that were untreatable. Stem cells, those remarkable entities that can transform into any type of cell the body needs, are being harvested, grown in laboratories, and returned to patients to repair damaged hearts, regenerate worn cartilage, restore function to injured spinal cords. The results are not universal, not miraculous in every case, but they represent a fundamental shift in what is possible. Researchers have learned to coax stem cells into becoming specific cell types: heart muscle cells, neurons, insulin-producing pancreatic cells, opening possibilities for replacing tissues lost to disease or injury. In some experimental treatments, patients blinded by damaged retinas have had their sight partially restored through the implantation of stem cell-derived retinal cells. Others with Parkinson's disease have shown improvement after receiving neurons grown from stem cells. The field is young, still finding its way, but the trajectory is clear. We are learning to grow replacement parts. Three-dimensional bioprinting takes this concept further. Imagine a printer that, instead of ink, uses living cells suspended in a gel-like substance. Layer by layer, it builds structures that mimic natural tissue. Scientists have successfully printed skin for burn victims, cartilage for damaged joints, even simple organs like bladders that have been implanted in patients. The technology is advancing toward the day when a patient awaiting a kidney transplant might receive one printed from their own cells, eliminating both the wait for a donor and the risk of rejection. The most precise tool yet developed for healing may be CRISPR, a gene-editing technology that allows scientists to make specific changes to DNA with unprecedented accuracy. Named for the repetitive sequences in bacterial DNA where it was first discovered, CRISPR acts like molecular scissors, cutting DNA at exact locations and allowing genes to be removed, replaced, or repaired. Diseases caused by single gene mutations, like sickle cell anemia or certain forms of inherited blindness, are now potentially curable through editing the faulty gene. Early clinical trials have shown remarkable results. Patients with sickle cell disease, who suffered years of painful crises and shortened life expectancy, have been essentially cured after their blood stem cells were edited with CRISPR and returned to their bodies. The corrected cells now produce healthy hemoglobin, ending a lifetime of suffering. Similar approaches are being developed for muscular dystrophy, cystic fibrosis, and countless other genetic disorders. The technology is not without risks. The possibility of off-target edits, ethical questions about altering human DNA, but its potential to eliminate entire categories of disease is undeniable. For those whose bodies have been damaged by injury, technology offers new forms of restoration. Brain-computer interfaces, devices that translate neural signals into commands for external devices, are returning agency to people paralyzed by spinal cord injuries. Electrodes implanted in the brain's motor cortex detect the electrical patterns associated with intended movements. A computer decodes these patterns, and a robotic arm moves, or a cursor on a screen responds, or in some cases, electrical stimulation is delivered to the person's own muscles, bypassing the damaged spinal cord and allowing them to move their own limbs again. A paralyzed man thinks about grasping a cup, and sensors in his brain capture that thought. Within milliseconds, His hand, stimulated by implanted electrodes, closes around the cup. He lifts it to his mouth and drinks. The movement is slow, requiring intense concentration, but it is his movement, controlled by his intention. Researchers are refining these systems, making them more intuitive, more responsive, working toward a future where the interface becomes invisible, where thought and action are reunited even when the body's natural pathways are broken. Wearable technology has brought continuous health monitoring out of hospitals and into daily life. Devices strapped to wrists or embedded in clothing track heart rate, blood oxygen, sleep patterns, physical activity, even the electrical rhythms of the heart with medical-grade accuracy. Algorithms analyze this continuous stream of data, learning each person's normal patterns and alerting them to deviations that might signal illness. A smartwatch detects an irregular heartbeat and prompts its wearer to seek medical evaluation, catching atrial fibrillation before it causes a stroke. A continuous glucose monitor allows a diabetic to maintain perfect blood sugar control without fingerstick tests. This technology transforms the relationship between patient and health. Instead of discrete visits to the doctor, health becomes a continuous conversation between body and monitoring system. Problems are caught earlier, when intervention is simpler and more effective. Chronic diseases are managed with precision, treatments adjusted in real time based on the body's response. The data accumulates, creating a detailed health history that reveals patterns invisible in traditional care. Virtual reality, once merely entertainment, has become a tool for healing minds and bodies. Burn victims undergoing painful wound care don VR headsets and immerse themselves in icy virtual worlds, walking through snow-covered landscapes while their bandages are changed. The distraction is so effective that many require less pain medication. The brain, fully engaged in processing the virtual environment, has less capacity to register pain signals from the body. Stroke patients relearn to move by practicing in virtual environments that respond to their efforts with encouraging feedback, accelerating rehabilitation. For those struggling with anxiety disorders or PTSD, virtual reality offers a safe space to confront fears. A person terrified of heights can gradually expose themselves to virtual elevations, their body learning through repeated exposure that the fear response is unnecessary. The virtual world feels real enough to trigger the fear, but safe enough to endure it. And through this exposure, the brain's alarm system recalibrates. Studies show that VR-assisted therapy can be as effective as traditional exposure therapy, and often faster. Precision medicine, the tailoring of treatment to each individual's genetic and molecular profile, represents perhaps the most fundamental shift in how we approach healing. Cancer treatment, once a blunt instrument that poisoned rapidly dividing cells without discrimination between cancerous and healthy, now increasingly targets the specific mutations driving each person's tumor. A biopsy reveals which genes are mutated, which proteins are overexpressed, and treatment is selected to attack those specific vulnerabilities. The healing available to you today would have been inconceivable to your grandparents, impossible to your great-grandparents. The pace of change is dizzying, accelerating, each breakthrough building on the last. Yet for all this technological power, healing still requires what it has always required: time for the body to respond, patience for treatments to work, the mysterious cooperation between intervention and the body's own wisdom. Technology cannot force healing. It can only create conditions where healing becomes possible. A surgeon's robot may remove a tumor with perfect precision, but the body must still knit the tissues back together. A gene may be edited flawlessly, but the cells must still integrate that change and function properly. An AI may diagnose disease early, but the patient must still endure treatment and trust in recovery. The machines are tools, sophisticated beyond measure, but still tools in service of the ancient biological processes that have sustained life for billions of years. Let yourself feel gratitude, if you can, for living in this moment of history. For the knowledge that if illness comes, if injury strikes, there exists an arsenal of healing technologies that previous generations could not imagine. But let yourself also feel connected to those ancestors, for whom healing was prayer and herbs and the laying on of hands. They too healed, though their tools were simpler. The body's fundamental capacity for restoration has not changed. We have simply become better at supporting it, at removing obstacles, at creating space for the healing that wants to happen. And so we return to this moment, to you, resting here in the quiet darkness. Your breathing slow and steady, your body soft and still. We have traveled far tonight, from the smallest molecules dancing in cellular spaces to the vast sweep of human history, from ancient shamans to artificial intelligence, from the cellular wisdom encoded in your DNA to the spiritual practices that connect you to something larger than yourself. All of it, every discovery, every tradition, every technique points to the same truth. Healing is woven into the very nature of life. It is not something you must learn or achieve. It is something you already possess, something your body has known how to do since before you were born, inherited from a line of ancestors stretching back through time to the first living cells that floated in primordial seas. Every person who has ever existed has carried this capacity within them. You are part of that continuity. The mechanisms are intricate beyond imagination. Immune cells communicating, genes being read and expressed, proteins folding into precise shapes, tissues rebuilding themselves layer by microscopic layer. Yet the principle is simple. Given time, given support, given the right conditions, the body moves toward wholeness. It wants to heal. It is designed to heal. Your task is not to force this process, but to allow it, to create space for it, to trust it. This trust does not mean passivity. You have agency in your healing. The choices you make matter. How you sleep and what you eat, how you move and how you rest, the thoughts you think and the practices you maintain. Whether you seek connection or isolate yourself, whether you find meaning in suffering or drown in despair, all of these shape the terrain in which healing unfolds. You can draw from the wisdom of ancient traditions and the power of modern technology. You can honor both body and spirit. You can be both patient and active, surrendering, and engaged. Right now, in this very moment, healing is happening within you. Cells are dividing. DNA is being repaired. Toxins are being cleared. Memories are being consolidated. The immune system is patrolling. The brain is preparing to cleanse itself during sleep. All of this occurs beneath consciousness, in the silent depths where your body's intelligence works without pause. You do not have to understand it for it to happen. You need only trust it, support it, allow it. So rest now, deeply and completely. Let go of any remaining tension. Let your mind drift where it will. If this journey has brought you peace, if these words have helped quiet your mind, consider sharing this video with someone who might need the same gentle rest. Every share helps another weary soul find their way here, to this quiet place of learning and letting go. For now, simply breathe. Let sleep come when it will. Trust that in the morning, you will wake slightly more restored, slightly more whole, carried through the night by the body's tireless work of healing. You are part of the great story of life continuously mending itself, and that story is still being written. Sleep well. Good night.